Hi, welcome back to Attacking and Defending Active Directory. In the previous videos, we discussed domain enumeration in depth. Now let's move ahead and follow the attack cycle which we discussed previously and see what is the next step. So we skipped recon for so that we can focus more on the Active Directory stuff. We did domain enumeration. Now is the time to cover local privilege escalation. So in any Active Directory environment, there are multiple scenarios, of course, which leads to privilege escalation. We've already seen hunting for local admin access on other machines with the help of find WMI local admin access and find local admin access. Similarly, we saw how we can look for sessions from high privileged domain accounts like domain administrators using PowerView's invoke user hunter. Uh, Before we move ahead and actually look for any of the previously discussed ones or actually exploit them, let's look for local privilege escalation. It really helps to have local admin privileges on your foothold box. You can always complete a successful red team operation without that as well. But there is no harm if we can escalate privileges locally on the foothold box. Now, on a Windows machine, how we can escalate privileges? There are a variety of ways. We can abuse missing patches, automated deployment, and auto logon passwords in clear text. For example, in automated deployments, there are well-known files like one in C Windows Panther called unattend.xml, which usually contains password of at least local administrator in clear text, if not the domain admin. Similarly, the file in C sysprep, I believe, called sysprep.xml, that also multiple times contains credentials in clear text. Then there are auto logon passwords which are stored in the Windows registry in clear text. Those could also be extracted. There are MSIs which are marked as always install elevated, which allow users, if they always install elevated setting is done, then any user can run an MSI or one MSI as system, which also may lead to privilege escalation easily. Then there are popular misconfigured service issues, right? Like unquoted service path or permissions with the service itself or permissions with the service bin path directory, etc. Then there are DLL hijacking opportunities, right? For example, if there is a service or an executable which runs with limited permissions, and you can uh, hijack a DLL, that is drop a DLL with what it is looking for, and then run the executable of the service, you may have your privileges escalated. So these are some of the common issues when we look at a Windows machine, not in the context of the domain, but as an individual box for privilege escalation. We can test for these things manually or with the help of uh, tools which make things faster, right? For example, we are going to have a quick look at PowerUp, BRoot, and Privesc, all open source tools useful for checking privilege escalation opportunities locally. In fact, in case of uh, in case of privilege escalation, as far as this class is concerned, we are going to have a look at only the service issues, right? Nothing else. That is, we are going to run the tools to check different things, but we are going to focus only on the service issues so as to spend more time on discussing the domain issues than the local privilege escalation. So once again, this is not going to be a comprehensive local privilege escalation coverage, right? Only something which we need to escalate privileges on our foothold box, right? So not an in-depth coverage. So as I said, we are going to focus on service issues. We can broadly, if we remove the DLL hijacking part, if we do not discuss that, other than that, service issues can be categorized or in three types, or they are of three types. One is the unquoted path vulnerability, where the service's bin path or executable uses an unquoted path and there is a space in the name which allows us to drop an executable in the service path, and therefore and thereby running our own executable in place of the legit one or the intended one. Then there are uh, services where we can modify its binaries path or change arguments so that we alter its intended functionality and thereby escalate our privileges. We can also uh, check for services permissions itself, right? Every service has its own permissions or ACLs. We can try we can check if the permissions on the service are not configured properly, and is there an option to change interesting properties of a service. What interesting properties? For example, with enough permissions, we can actually point our service to a different executable at all. There's no need to overwrite the executable, but we can simply point our service to a different executable, and that executable will then run with the privileges of our service, right? So let's run get service unquoted first, or in fact, let's first see what the unquoted path vulnerability is. Let's say we have, first of all, before that, uh, uh, okay, let me explain what unquoted service vulnerability is. Let's say we have a service installed in this path. Let's call it CFTP server. FTP server. Note the space here, right? Please note this. FTP server, and then run FileZilla. Let's call it FileZilla. And FileZilla is not vulnerable to this, but just an example, FileZilla.exe. Right? Let's say this is the executable for our service, and this path is unquoted. What does that mean? That means if we have write permissions to this directory, to the FTP server directory, we can always drop an executable like this. And if we restart the FileZilla FTP server now, in place of this executable, which is the intended one, our planted executable ftp.exe, that will get executed, right? This is how Windows services work. If it spots a space and there is an ftp.exe here, this particular executable will be executed. Why? Because there is no code here. Windows has no idea what the complete path to the executable is, right? If it was something like this, in that case, this particular service would not be vulnerable, right? Literally unquoted service path, right? So if I run get WMI object, for example, class win32 service. Now I'm showing you how the service bin path looks like. Uh, so let's filter on the basis of path name here. So if I simply run select path name, you can see that for all the services on this current machine, this is the bin path, or that is, these are the executables. So what an unquoted path vulnerability looks like is, let's see if there is any service with an executable or bin path or path name which has a space in between, but there is no code. Let's see if we have something here. So it doesn't look like that, right? If it was unquoted, this may have been useful if we have the rights to drop an executable here, right? at windows.exe. So there doesn't look like that there is anyone here, right? Apart from the first one, I'm not discussing that deliberately, right? That is the one which we know. That is the one which is vulnerable actually, right? The path name is unquoted, right? And we can drop an abyss.exe here to abuse it. Now, this is what unquoted path vulnerability is. And we can use get service unquoted, I believe, from power up to get service unquoted from power up to look for those services which have unquoted paths. In place of running these functions one by one, we will run all of these together later on. Right? What get modifiable service file does is to get services or retrieve services where the current user can either override its binary or change the arguments. The third option, or the third vulnerability or misconfiguration, as we discussed earlier, it is where we can modify the service itself and temporarily make it point to another executable, right? That is, if with enough permissions, we should be able to, for example, we modify, let's say, this service and point it this executable so that the service doesn't point to this but to our payload or cmd.exe or PowerShell.exe or whatsoever we want, right? So this is what three types of service issues which we are interested in right now. Once again, we are not discussing local privilege escalation in very depth. Now, we can run all the checks for whatever local privilege escalation opportunities are there to discuss from the tools which we are using. From power up, we can run invoke all checks. From broot, we can run the executable broot.exe. From the privask tool, we can run a privask.ps1 script which loads this function invoke privask. So let's run these. So first of all, let's run power up and run invoke all checks. So what power up checks for? Checks for unquoted service paths. So it shows us the Abyss web server service, which we identified manually as well. That is, there is a space in the path right here, but the path of the executable or the path to the executable is not quoted, right? Now, a couple of additional things to keep in mind whenever we try to abuse unquoted path vulnerabilities. One is the privileges with which the service runs, right? It must run with some higher privileges than what we have currently. Secondary, we must have the capability or permissions to restart the service. Although we can always wait for the service to restart automatically or someone else to do it or the machine to reboot, it always makes sense to target a service which we can restart at our will, right? So please keep this in mind. Now, another thing before we jump on to the other options is to look for some tools may actually report anything like this as vulnerable. I don't think that is there is such service in case of this Amazon instance, but in some cases, let me run this on my host machine so that I can explain it better. So here we can see that we have a service like this. So please keep in mind that this particular service even if it is reported vulnerable or abusable by any tool, it is actually not vulnerable. Why? In case of this, where would we need to drop the executable? We need to drop a file called program.exe in the root of the C directory to abuse this one. Now, to be able to drop any file to the root of the C directory, we need to actually already have administrator privileges, right? So please keep that in mind, that if any tool reports this particular stuff as vulnerable, it is a false positive. Although please keep in mind that if there was, let's say, a space here between wonder and share, uh, it may be possible for us to drop a wonder.exe and abuse this one, right? So please keep that in mind. Do not trust the tools blindly. They are just written by fellow hackers and security professionals to make things fast. Those tools are not absolute truth, not the neither their output nor the tool writers or anything else, not me as well, right? So that was the unquoted service path. Now the next thing which we discussed was if we have enough permissions to override the service executable or its arguments. So turns out that the Abyss Web Server Abyss Web Server's permissions are pretty messed up. We can actually override the service binary as well. That's what it reports. PowerUp reports. You can see that PowerUp not only detects an abuse, it also provides you an opportunity or ready to use functions to abuse that functionality, right? For example, in case of unquoted service path, it provides an abuse function called write service binary, which actually writes out a binary for you to drop in the desired path. Similarly, in case of argument permissions, you have install service binary and restore service binary, wherein you can override the binary as well. Uh, so PowerUp also reports Google update.exe, which is for probably installed when I installed Chrome on this machine. Uh, so is it actually abusable? So we have permissions to append data and add subdirectory. Modifiable identity is built-in users. We cannot restart it though, but I've not tried this one. Feel free to try this. You do not have the restart permissions, but you will have the permission to restart the machine. So feel free to try this if you have Google Chrome installed on your uh, student boxes. Third one is the service permission issue. This is quite simple to abuse. What we can do according to this output is we can actually change this. What is this? This is the bin path or path for the service. This is the executable which runs as the service. We can, according to this output, we can actually make the Abyss Web Server service point to a new executable. Let's say cmd.exe or PowerShell.exe or whatever exe you want, right? And we have the restart permissions as we have seen earlier. This runs as a local system. So this is ripe for abuse. Then there are some potentially hijackable DLL functions. We are not going to have a look at that. Let's very quickly, just because we mentioned the tools, let's quickly have a look at the output of broot and prevesc as well. So if I run broot, uh, once again, we are more interested just in service issues right now. So we are going to skip past anything else. Okay, so okay, it first checks for the service issues. It checks services that could whose configuration could be modified. So for Abyss web server, we can modify its configuration, right? Uh, that means, so there are multiple issues. There is a writable path we can drop as we discovered there. There is a writable path C web server where we can drop abyss.exe. Uh, What else? Binary located on a writable directory. It also checks that that means that we can overwrite abyss ws.exe, the legit file. And does it check for the service permission issue as well? Uh, doesn't look like that, but we identified a couple more issues with this particular tool called broot, right? Aptly named. Now let's try Privask as well. So if I load Privask, oops, not the bat, but the PS one, and let's run invoke Privask. So checks are always install elevated, rotten potato, no. Identifies that Abyss web server is abusable because of the unquoted service path, and suggests the Metasploit module to be used to exploit it. Uh, okay, it is still running. We can leave it running, right? Okay. Okay, it is not checking service permissions. Let's see if it finds out anything. I think I pressed a key here. No. So we can override services. That's what this tells. That is, we can override the executable for this particular service. Right? Let's stop this. So this way we identified that there are multiple ways of abusing service permissions. Just one of the ways, right? We discovered multiple ways, and there are so many ways of escalating privileges uh, on a Windows machine. In fact, if I have enough requests, I may create a separate course for this, right? So this is how we escalate our privileges using oops, using local issues on a Windows box, right? So I think that would be all for this video. In the next video, we will have a look at another uh, popular privilege escalation opportunity, that is by abusing enterprise applications which are widely used. Right, so that would be all for this video. Thank you very much for watching.